Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smartyurl.it/Jedi. My advice on how to pass actuarial exams is at smartyurl.it/pass. This video channel is at smartyurl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smartyurl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smartyurl.it/help-ISU-actuary. Here's a problem for today. For exam P on probability, a company provides each of its employees with a death benefit of 100. The company purchases insurance that pays the cost of total death benefits in excess of 400 per year. The number of employees who will die during the year is a Poisson random variable with mean 2. Calculate the expected annual cost to the company of providing the death benefits, excluding the cost of the insurance. And here's the solution. So let's write n for the random number of employees who die in a year. Then we know that n is a Poisson random variable. No, it's Poisson with mean 2. Note that the random cost of the death benefits for the company is 0 when n is equal to 0, 100 when n is 1, 200 when n is 2, 300 when n is 3, my apologies for a typo here, and 400 for n greater than or equal to 4. Therefore, the expected cost of the company is, 0 when n is 0, so 0 times probability that n is 0, plus 100 times probability that n is 1, plus 200 times probability that n is 2, plus 300 times probability that n is 3, and then for any n greater than or equal to 4, the payment that the company makes is 400, because any excess over that is covered by the insurance policy. And now, what I'm going to do is I'm going to kind of flip it and take 400 times each of those probabilities and subtract what is needed to be subtracted to leave what we have here, because this way I can write this as 400 times each of the probabilities, that n is 0, n is 1, n is 2 for every value. So 400 times the sum from n equal to 0 to plus infinity of the probability that n is n, and minus what I need to subtract, which is 400 times the probability that n is 0, 300 times probability that n is 1, 200 times probability that n is 2, 100 times probability that n is 3. So this becomes, the sum of all these probabilities is 1 because it's a probability distribution. So it's 400 minus 400 times 2 to the 0 times e to the minus 2 over 0 factorial minus 300 times 2 to the first times e to the minus 2 over 1 factorial minus 200 times 2 squared times e to the minus 2 over 2 factorial minus 100 times 2 cubed times e to the minus 2 over 3 factorial. That's 400 minus 100 times all these terms that we have here, which is 4e to the minus 2 from the first term, 6e to the minus 2 from the second, 4e to the minus 2 from the third, and 4/3 times e to the minus 2 from the fourth. And this altogether becomes 400 minus 4600 over 3 times e to the minus 2, and we calculate it to be approximately 192.485899, and that's answer C. Please remember this is copyrighted material. The problem itself comes from the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.